Hello world. The goal of today's demonstration is to show connecting IO-Link sensors to the ctrlX core data layer. Specifically, we'll be using Bosch Rexroth S20 IO-Link IO-Link Master module, part of the S20 IO family. And we're assuming that you're already familiar with setting up a ctrlX core and that you've already downloaded ctrlX Works version 1.18 or higher. Today, I'll be working with Kiosk 2 from our Factory of the Future room, where we offer live and remote demonstrations of the ctrlX platform. You can see here that we have a ctrlX core connected via EtherCAT to a remote I/O bus coupler, and our IO-Link Master is connected here to a temperature sensor. For our learning objectives, we'll be setting up a EtherCAT Master topology using ctrlX IO engineering, and with ctrlX PLC engineering, we'll be using function blocks from the ctrlX S20 library to configure IO-Link Master module. And then we'll end the demonstration with a practical example of pulling the sensor reading data into the PLC program. Looking at our hardware topology, note that the IO-Link Master module is in slot 2. We'll need that info for later. Today, we'll just be focusing on the ctrlX core, the EtherCAT bus coupler, and the IO-Link Master module. So that'll involve the EtherCAT Master topology in the core, and then using PLC engineering for the communication configuration to the IO-Link Master module, and then port configuration of the ports on the IO-Link Master module. Now let's transition to the live demonstration. So I've just connected to my ctrlX core. Now if we go down to Settings and Apps, you can see here that I have version 1.18 of the EtherCAT Master and version 1.18 of the PLC app. Now let's look at setting up the EtherCAT Master. I'll come here and add and use the default naming. Now clicking on the master, we'll start ctrlX IO engineering. Starting with a basic program, I'll first come to my EtherCAT Master and scan for devices. And we'll insert all newly scanned devices and apply. Okay. Now if we look here, the ctrlX IO was automatically added, but for the S20 coupler, we'll come in and manually insert the devices. So my first device was a digital input-output, and then the IO-Link Master. Now that we have our topology, we download it to the core. Okay, now that we've successfully set up that, we can come back to the web interface and we can see that all our devices are online. And note that the address of the S20 EtherCAT bus coupler is 1004. Now we're ready to come to the PLC program and set that up. Okay, so starting with a basic PLC program, I'm first going to come here to the data layer and insert the EtherCAT topology that we just set up. And we'll select all devices. Now, if we come down here to the S20 bus coupler, we'll go to the IO-Link Master and make sure that it's enabled. Note that if we enable the digital input-output, it'd be ready to use, but because the IOL8 requires an additional communication protocol of IO-Link, we have to add in function blocks for the communication configuration. So we will find those necessary function blocks in the S20 library. Now if we open up this library, we will see here for IOL8, function blocks we gain access to are set port config and get live port list. So set port config requires an input of an S20 bus handler and an array for channel configuration. And we have to note what slot the module is on. Again, that was slot 2 in our case. Looking at the get live port list function block, again, it also requires that communication bus handler that we'll configure. And it outputs into an array what the active port configurations are detected on the various ports of the IO-Link Master. So we're going to add a POU for configuration of the S20. And today we'll be programming in structured text. So first we'll have to add our variables, and today we'll just be using example code provided in the library itself. So I'm copying the declarations for the S20 COM configuration for setting up the COM configuration tied to the bus coupler, and also the variables necessary for port configuration. And here's where we will declare that our UI slot is on port 2. Now I'll come back to the example code and just borrow the code offered here. So now we have our function block set up for set port config. Now I also want the code for getting the live port list. We'll come back here and borrow the example code again. Now, I already copied in the variable declarations for COM configuration. I just need the variable declarations for get live port list. Now we have some errors here. That's because the same naming convention was used for get live port list as for set port config in our code example. So we'll update that. We've already declared the UI slot in the variable declaration above, so we don't need that line of code. Now we'll come back for the chunk of code that we need from the example for get live port list. Next, we need to update the naming convention to match our variable declaration above. Now let's take a moment to review our code. So again, our first chunk of code here is the function block for COM configuration for the S20 bus coupler that sets up our EtherCAT Master. We'll update the slave address to 1004 to match our EtherCAT topology. And then, again, our UI slot is slot 2. Make sure that's correctly updated. The next chunk of code is set port config, which activates the ports of the IO-Link Master module. And get live port list allows us to see what the active configuration is of every sensor connected to the IO-Link Master so that we can properly set the channel configuration here in set port config. So let's build our code just to make sure there are no errors. And we're ready to go and add the S20 config POU to the main task. Now we're ready to go online with the program. So I'll log in and we'll download our latest code. Now let's make sure our program is running. So if we come to our S20 config POU, let's first look at the configuration array. We have 8 arrays here, 1 for each port. If we look at port 1, we can see that we have an option to set up the port mode. So you can set it up for IO-Link, digital input, digital output, or disable it. And then each port also requires the vendor ID, device ID, and info about the process data input and output length. So where do we get this data? We get it from the get live port list function block. So our first step will be to activate every single port on the IO-Link Master. Now you can either use debug and write values. I'm just going to use the shortcut command of Control F7. So we've just activated all the ports of the IO-Link Master. Now we can come to get live port list and activate this function block to read how they're all configured. So if I come back up here to our live variable list, let's look at the array for get live port list. If we look first at port 2, we'll see there's No data there because we do not have an IO-Link sensor connected, but we do have our temperature sensor connected on port 1. And we see now that we have the vendor ID, device ID, and the process data input length of 64 bits. So this is the info we need to now plug in to our port configuration. And again, I'm just going to use Control F7 to write that info in. All right, now that we have the correct configuration data for the IO-Link temperature sensor connected on port 1, we will come back to our code here and re-execute set port config. This will require seeing a new rising edge to re-execute. And it's worth noting that for any unused ports, it is recommended that you come and deactivate those ports. Now that we have our sensor correctly configured on port 1, we can come over to our data layer and we should see live data. Here you can see now this is the temperature sensor data being read, and up here this is actually data on humidity. To finish the demonstration, I'll show taking the data from the data layer and bringing it into the PLC program in a practical way. So we'll add some new code to come offline. And if I come back down to my process input data, I know from my sensor data sheet that the temperature sensor data is coming in actually on bytes 4 and 5. And that's the high bit and the low bit. So I'll add in some variable declarations. Next, we'll come to the application and we'll add a global variable list where we'll add variables for the temperature in Celsius and Fahrenheit for theoretical use throughout the program. Now in my PLC program, I'll write some basic conversion code. And again, from my datasheet, I know that this data needs to be shifted by 0.01. And this will automatically turn the word created by concat byte into real type data. Then we'll do a quick conversion to Fahrenheit as well. And again, let's build the code to check that there are no errors. So let's go back online now and test that out. Run the code. And now we have two variables to use throughout our PLC code or to send to an HMI. That concludes our demonstration for today. Thanks.